Okay, so welcome all to this chapter. I do believe that it's chapter 13. Here we will deal with decomposition. In short, this chapter we will mainly encompass parts about software development process that's basically called decomposition. You will see why this is so useful because we'll be separating our code into different files. Basically, decomposition means segmenting the code into smaller parts, mostly for easier reading and maintenance. We have already seen decomposition at work, to tell you the truth, in our earlier tutorials where we've basically segmented functions. Do you remember when I typed in a function prototype up above, and then down below the main, I've actually written out the body of the function? That was an example of decomposition, because we had a clear overview of all the functions that we had up above, and down below we had the bodies of those functions. Now, classes structures, they are divided into two parts. You have definition and implementation. In the definition part, we write the class prototypes, and in the implementation part, we implement those classes. Pretty much a very similar concept to the one with the functions, where we've created the prototypes of the functions, and then we've created and then we've actually implemented the functions, where we've created the bodies for those functions. In the definition part, we write the class prototypes, and in the implementation part, well, basically we implement those classes. We do all of this just to make our code readable, more readable, so to say. It makes very little to no difference to the machine at all. So when the user takes a look on the part that contains only definitions, they're able to understand what it is and what it can be used for. What does that class actually contain? However, if they are interested in how a certain part works, they can just check that particular part. They can look at the implementation of that part. However, it might happen the user does not have access to the implementation part. This is usually because it is hidden, protected, or proprietary. In that case, it is necessary to do the decomposition of the code. So, for simplicity's sake, we will use our simple version of the class date. So it's right here. Hopefully you didn't delete it. I didn't. I've left it here, and I've asked you to leave it. And then we're gonna go ahead and split it up apart onto two parts. You will have the header and you will have the CPP file. So we will need to create a date.h, and we will need to create a date.cpp, where we will write those two integral parts of the decomposition. Anyway, let's go ahead and explain some basic things about the date.h. First of all, we need to make it. So go ahead and right-click on right-click on the project, and then should be like project tree, remove add files. Okay. No, sorry, not a. There should be a create, for crying out loud. I generally don't work in code blocks. Build option, properties, open project folder in the file browser format. Come on, my good man, where is it? No, I don't want to find build categorize. I cannot believe that it is not here, seriously. Let's just go about this. A new class, sure. So just go ahead. It's going to be automated, if I remember correctly, in code blocks. It's going to create the CPP and the .h file by default. But in case you're using some other IDE where this does not happen, you can just manually create those two files. So just go ahead and click on File, then go on to New, then go on to Class. And we're going to need a class name, which will be date.cpp. Oh, sorry. Just going to name it date. And as you can see down below, it actually does this for us. I haven't used code blocks in forever in this fashion. That's why I'm a little bit rusty. So it says file name, date.h, And okay, it's going to create the guards for us. I'll explain that in a moment. And then it then says generate implementation file, and this is the header file. So you have the header file and you have the implementation file. The header file is date.h and the implementation file is date.cpp. And by default, it will actually include the date.h. So this is the automated process in code block, but these files can also be created manually by just going into the project, basically right click, create new file, date.cpp and date.h. So let's go ahead and click on create. The new class has been created. Do you want to add it to the current project? Yes, we would very much like to do that, and click on OK here. Okay, so now it says headers here. Include date.h, source src. If I just click plus on it, you will see that it does contain date.cpp. Okay, let's zoom this in a little bit, and let's zoom in the header a little bit. Now this is very nice that CodeBlocks does these things for us, but we're going to go ahead and delete all of that. And in the date.cpp, we shall delete it as well, although we won't be doing anything drastically different there than what the CodeBlocks has done by default, pretty much. So it's important that you create these two files. The manner in which you create them, it's completely up to you. So the first thing that we will need to do in the header file will be to basically do this: if and def space date underline h, and it's gonna in an automated fashion create the end for that, and then we're gonna go ahead and type in define date underline h. So if not define, right. So if not define, define and end. So this above is what you see here, what you're looking at now. This is the include guard. It prevents from including the same files multiple times, which would result in multiple variables, functions, classes with the same names. Pretty bad. Of course, the program would not compile in that case as well. So the include guard consists of the following. So you have if and def date underline h. This is a preprocessor command that checks if there is a constant defined. So if and def means if not defined. So right here, if and def, if not defined. The name of the constant, however, is arbitrary, but it has to be unique. To make sure that we have the unique names, it is considered a very good and sound practice to name the constant the same as the file in which it is defined. We know that we can't have two files of the same name in one folder, so that way, if the name of the constant is the same as the name of the file, we simply change the dot into the underscore. Oh yes, look. Date underline h instead of typing in date.h. So date.h here would be date underline h. In such a way, we are ensuring that the name is unique. If we have multiple files that are the same but in different folders, I don't know, then you could just type in something like this: folder 1. Let's say that could be it. As long as the name is unique, you should be good to go. Of course, as I said, these are just recommendations. Constant names are arbitrary. As long as it's unique, you should be, as I said, good to go. Also, because these are macro commands, they're usually written in uppercase letters. So usually, as I said. And down below, where it says define date underline h, this is where we define the unique constant. Down below, it says end if. This indicates the end of the include guard. Okay, so now that we know those basics, we can go ahead and start writing out our code. So same as before, include include IOStream. That's fine. This is our basically. Now we're going to write out our class, but methods will not have bodies. They will just be prototypes. This is also called the class interface if you find it somewhere in the literature. Class date. And down below we shall start writing. So we want our variables to be private. So we shall type in int day, int month, and int year. And now we shall go into the public place, so to say. Okay. Painstaking process. Why are you doing this? I do not want you to behave in this fashion. Excellent. So here we will do the method we will create the prototypes for the methods. I'll type in void set date. It's going to be int d. Void set date. It's going to be int d and int m. And we shall go about this typing in int y, semicolon here. So I'm gonna cut the tutorial here because I don't want to make it too long, and then we shall continue. But we shall simply continue by prototyping the rest of the functions here. Anyway, see you in the follow-up.